One day, NASA will build a spaceship that can take us anywhere in the universe. Probably. And when this happens, we'll be able to find a new, beautiful home. Scientists even know what exactly they're looking for. We want a planet about twice the size of Earth with an average temperature of 77 degrees Fahrenheit, with a pretty dense atmosphere. Bigger planet means more room for water and potential homes. And a dense atmosphere means more protection from nasty space stuff, as well as more lush plants and cool animals. Thanks to the James Webb Space Telescope, we can now study exoplanets better from a distance. Of course, sending astronauts there would be much better, but oh well. Discovering new planets isn't easy though. It's like trying to find a tiny firefly in a pitch-black forest. Scientists had to come up with a clever method to find very distant planets. It's called the transit method. Here's how it works. Scientists capture a series of snapshots of a distant star at different points in time. Then, they scrutinize these images. They try to find any mysterious dark spots passing in front of the star. If they find one, it could very well be a planet. These snapshots hold the keys to uncovering vital information about these distant worlds. Not only do they tell us that there's a planet there, but also reveal its size, radius, and how close it is to its parent star. And most excitingly, they hint at whether it could ever become a new home for us. And now their research is finally bearing fruit. Recently, we've stumbled upon a tiny world nestled in the Cygnus constellation. It's called Kepler-22b. At first glance, it might not seem like a big deal, but this discovery has some pretty huge implications. This planet is located right in the Goldilocks zone. The Goldilocks zone, also known as the habitable zone, is a sweet area around a star where the conditions are just right for a planet to have liquid water on its surface. It's not too hot, so it doesn't evaporate, and it's not too cold, so it doesn't freeze. Hence the name from the famous story of Goldilocks and the Three Bears. So there might be water on Kepler-22b, and where there's water, there's a chance for life. And it's not just about life. Having a planet covered in oceans can be a game changer for climate stability, all because vast water bodies act like nature's thermostats. When the sun beats down on the hot parts, the water soaks up some of that heat and spreads it around like a blanket. The scorching regions cool down and the icy ones warm up and thaw out. Back in the bad old days of our Earth, the moon played a crucial role in helping water puddles spread across our planet. This is what helped our world transform from a fiery nightmare into the vibrant, life-packed orb we call home. Kepler-22b has about the same year length as our Earth. And if we're right about the whole ocean thing, scientists think its average temperature could be around a cozy 12 degrees Fahrenheit. But if this world also sports an Earth-like atmosphere, temperatures might soar up to a toasty 72 degrees. This world isn't too far away from us, only 635 light-years, which is about 3 quadrillion miles. Yeah, that's pretty close in space terms. Its sun is a yellow dwarf star, just like our sun, although there's a subtle difference. It's about 20% dimmer, so you won't see this star in the night sky even if you squint your eyes really hard. This star also happens to be quite chilly. Its temperatures are hovering around a frigid 10,000 degrees Fahrenheit, making it the Arctic of the starry skies. Luckily, Kepler-22b snuggles up to its star a bit more closely than we do to the sun. If it was in our solar system, it would find its place somewhere in between our familiar Earth and Venus. So the brightness and the temperature on this planet would be almost the same as on Earth. There are a couple of catches though. For example, this world might be quite a gymnast. It could be twirling around its star in a totally different way than Earth does. It might be tilted, like Uranus. If that's the case, the temperatures of the planet could be quite weird. You'll experience bone-chilling winters, followed by scorching hot summers. So let's hope this theory isn't true. If Kepler-22b has a normal tilt, its climate would be pretty similar to what we enjoy here on Earth. The next problem is gravity. Kepler-22b is about 2.4 Earth's size, which means the gravity there would be stronger. You'd feel noticeably heavier on this planet. It would be just like doing your everyday activities on Earth, but everything would require more effort due to the stronger gravitational pull. Simple things like climbing stairs or even just breathing would require much more energy. So it's time to build some muscles. People would have to adapt to the new conditions by having denser bones and more robust cardiovascular systems just to move around comfortably. Unfortunately, that means doing sports would be much harder too. But hey, at least people might need to consume more calories to sustain their activities, so even though you'd have to exercise more, you'll also be able to eat more delicious food. Buildings on Kepler-22b would likely be square and robust to withstand the stronger gravity, which would kinda be problematic because taller structures are super challenging and expensive to build. But the most important question is, what kind of planet is that at all? Yeah, it's the big question mark. Scientists aren't even sure that Kepler-22b is Earth-like. It could be a gas giant or even a water world. A water world is a planet with a vast ocean covering its surface, and it's not just some knee-level deep water. It'll be insanely huge, thousands of miles deep and more, with no visible surface or any plants around for a long time. In that case, we could dream of building underwater cities. We could filter the water for sustenance and perhaps evolve into amphibious beings. Would that be a step backward or a leap forward in our evolution? Some scientists also lean towards the idea that Kepler-22b might be a mini Neptune. This is a legit planetary category, by the way, but that theory is still unproven. But let's say, for our sake, it's a rocky planet. Even then, we're in the dark about its atmosphere. Does it even have one? What if it's like Venus, toxic enough to make your ex look like a bouquet of roses? In that case, we'd have to dig deep into the planet's depths for survival, figure out a heat source, and hope for the best. While there's a lot we don't know, let's keep our fingers crossed and assume the planet is Earth-like. In that case, what would Kepler-22 look like? Well, because of stronger gravity, the planet's landscape might be full of rugged mountains, deep valleys, and powerful rivers. If there's life on this planet, it's probably quite small? Unusual plant and animal life should have adapted to the higher gravity. Trees might be shorter and sturdier. They'd struggle to break free from the soil. Animals might be pretty small too. They would also have strong, muscular legs for support. Perhaps these creatures would have numerous legs, making movement possible. They'd need to be small in stature, but gargantuan in strength. Muscular giant spiders sound not so bad, right? As for our beloved pets, they'd have to become little muscle-bound spheres just to survive. Also, the landscapes would feel very spacious because of the planet's sizes. A 3-day flight in a plane sounds like quite the adventure. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer the planet. That would be awkward if it turns out to be a gas planet or something like that. For decades now, scientists have been discovering new planets outside our solar system. By 2023, we've found more than 5,000 of them, and many of these exoplanets could potentially even have life. Now, if you're ready for a wild ride through space, let's find out what potentially habitable planets we've discovered in the last few years. LP890-9b and LP890-9c. Buckle up because we're heading to LP890-9, a red dwarf star located a whopping 105 light-years away from Earth. This star is quite cool compared to our Sun, in terms of temperature, of course. It has a temperature of about 4,700 degrees Fahrenheit. Now, this little guy may be small, but it's packed with surprises. For example, 2 exoplanets orbiting around it. Moreover, both of these planets are likely terrestrial, meaning they are rocky, just like Earth. First up, we have LP90-9b, which was discovered in 2022 using the TESS telescope and later confirmed by the Speculoos telescope. This planet is a super-Earth, weighing in at about 13 times the mass of our own planet. It's also slightly bigger than Earth, with a radius about 1.3 times larger. And if you thought Mercury's orbit around the Sun was quick, just wait until you hear about LP 890-9b. It takes about 3 days to complete one lap around its star. Imagine falling asleep in freezing winter and waking up in hot summer. But the real showstopper here is LP 890-9c. This one was discovered by the Speculoos telescope. It's a bit further out from the star and takes a leisurely 2.5 times longer to orbit than LP 890-9b. It's also a bit larger than Earth. But its real claim to fame is its location within the habitable zone of its star. That means it could potentially have liquid water on its surface and a climate suitable for life. Now this planet becomes a prime candidate for studying its atmosphere using the James Webb Space Telescope. But hold on. It's not all sunshine and rainbows for LP 890-9c. It's also really close to its star, meaning it's full of radiation that could potentially make it less habitable. And to top it off, it's tidally locked, just like our moon. That means one side of the planet is always facing the star and is incredibly hot, while the other is always in the dark and really cold. Scientific models suggest that this planet could be more like Venus in terms of its atmosphere and climate. And Venus isn't known for being human-friendly. But despite these challenges, LP 890-9c is still a fascinating exoplanet worth studying further. Who knows what secrets it may hold? Let's move on to the next candidates. GJ1002b and GJ1002c. An international team of scientists, led by researchers at the Instituto de Astrofísica de Canarias, has found two Earth-like planets just 16 light-years away from our solar system. They both orbit a red dwarf star called GJ1002. Our Sun is a yellow dwarf, which means that GJ1002 is much cooler and fainter than our own Sun. But that's okay. Both planets are very close to its star, so it shouldn't be too cold or dark on them. These planets, called GJ1002b and GJ1002c, are both in the habitability zone of their star, meaning they could potentially support life. Also, both of them have masses similar to that of Earth. GJ1002b is the inner planet and takes about 10 days to orbit its star, while GJ1002c takes a little over 21 days. These planets are great candidates for studying their atmospheres and could even be targets for future missions to search for signs of life. The most important thing is that these two planets could potentially support life, and that's pretty cool. Plus, the fact that they're located so close to us means that we might be able to visit them someday. Well, maybe not us personally, but And maybe one day, we'll even find some extraterrestrial life on one of these planets. Now that would be out of this world. But moving on to the next one. Kepler 1649c. Kepler 1649c, also known as the Lost Exoplanet, was rediscovered in 2022 by scientists using data from NASA's Kepler spacecraft. This exoplanet is located about 300 light-years away from Earth and orbits a small, cool star called Kepler 1649. It's about the same size as Earth, and just like the previous ones, it's located in the habitable zone of its star. Initially, the data about this planet was discarded. A special computer program called RoboVetter, written to automatically sift through the volumes of Kepler data, labeled this candidate as a false positive. In other words, the program thought it was just some kind of an error or interference. Fortunately, the researchers double-checked such things, and when rechecking the data, they managed to rescue poor Kepler 1649c. Now we know that this is a terrestrial planet just like Earth, and if it really does contain water, there could even be life there. But don't pack your bags just yet. There are still many unknowns about Kepler 1649c. For example, we don't know what its atmosphere is like or what kind of surface it has. It's also possible that the planet is tidally locked. Just like LP 890-9c, That would be, unpleasant. That's why Kepler 1649c is definitely worth further study. Maybe it turns out to be a perfect place for us to set up a vacation home in the future. Just make sure to bring plenty of sunscreen since the planet is pretty close to its star and things could get pretty toasty. Kepler 1638b. This exoplanet is located about 5,000 light-years from Earth in the constellation Cygnus. It's also located in the habitable zone of its star. It was discovered in 2020 by the Kepler spacecraft through the process called transiting. They basically take a bunch of photos of the star at different times. After that, the programs analyze these photos and look for small spots and dots on them. These tiny dips in brightness may mean that a planet was passing by the star. Kepler 1638b is a bit of an oddball compared to most exoplanets we've found so far. It's about 4 times the mass of Earth and has a radius about 2 times that of Earth, making it a super-Earth exoplanet. Its orbital period is about 260 days, which is quite close to our Earth, and that's great! Finally, at least somewhere, winter and summer will flow normally. Kepler 1638b could have some liquid water there. That's why it's also a good candidate for further study, to see if it could potentially support life. Let's hope that we'll find out more about this planet in the future. And finally, the last one. Kepler 438b. Kepler 438b is an exoplanet located approximately 640 light-years away from Earth in the constellation Lyra. It was discovered in 2015 by the Kepler Space Telescope. One of the most interesting things about Kepler 438b is its size and location. It's about the same size as Earth and also orbits within the habitable zone of its star. But there are a few catches. For one, Kepler 438b orbits around a red dwarf star, which are known for their high levels of solar radiation and flare-ups. This could make the surface of the planet too hostile for life as we know it. In addition, Kepler 438b has a much shorter year, only around 35 Earth days long. This could lead to extreme temperature fluctuations on the planet's surface, but maybe it's home to some hardy extraterrestrial life forms that have adapted to its unique conditions. Or maybe not. Either way, it's definitely worth keeping an eye on. This is a small list of exoplanets that we've discovered in recent years. Now, with the use of new technologies, we'll be able to find new exoplanets much more often. Let's hope that at least a few of them will really be inhabited. An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or two. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, Much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light-years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than negative 360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its two parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP-12b travels so close to its host star that it needs just one day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP-76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP-76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP-76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways. So it's probably not the place where you'd like to spend your vacation.
Okay, here you are in the middle of the ocean. It's endless, but you can't see it because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans, its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface, but if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214. An unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the Sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? All right, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves.
A new study has just made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took shapes that defied any expectations. The thing is that even though more than 5,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. After examining the formation mechanisms of gas giant planets like Jupiter, the team came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of planetary seeds, resulting in the appearance of massive planets, sometimes larger than our solar system's largest giants. The standard theory of the formation of planets suggests that such growth occurs gradually and smoothly. First, dust particles start sticking together, forming progressively larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This idea involves a protoplanetary disk, a disk of gas, which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and planets are hypothesized to form from this cloud. Protoplanetary disks are believed to be common byproducts of star formation and range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability method. The model built by the team seems to support this second, less favored theory, rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions drawn by the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they are angled. If Earth is directed face-on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real smarty. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they will find out the role the environment around a young planet plays in affecting its shape and formation. Observations of young planets, which are often still surrounded by gas and dust, have become possible only recently. All thanks to such telescopes as the Atacama Large Millimeter Array, the ALMA telescope, and the Very Large Telescope. These observatories might provide additional data to support the Smarties theory. By the way, the construction of the ALMA telescope involved thousands of scientists and engineers from all over the world and lasted more than 10 years. The observatory is among the highest instruments in the world, at an altitude of 16,570 feet above sea level. This puts it above much of Earth's atmosphere, which tends to blur and distort light, disrupting observations. Plus, ALMA is located in Chile's Atacama Desert, one of the driest places on our planet. That's why, almost every night, the sky is clear of clouds and free of light-distorting moisture.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye, because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the Moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claim to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Dark, mysterious, cold space. Comets, asteroids, planets, stars, and something that's lurking over there, far beyond Pluto. Yup, this could be the 9th planet of our solar system, the one people have been wondering about for centuries. IRAS, which stands for the Infrared Astronomical Satellite, collected interesting data back in 1983. It could be proof that Planet 9 is hiding there. No one knows if it really exists, but this discovery helped to build a model to understand this potential planet better. And in 2016, scientists found out that some small space objects in the Kuiper Belt were orbiting a bit oddly. The Kuiper Belt is the outer area of our solar system. It's a ring in the shape of a donut, filled with leftovers from the times when our solar system was forming. You can find this donut beyond Neptune. The objects in that region of space have weird orbits, almost as if a big body with strong gravity is pushing them away. Knock knock, Planet 9 again. The theory says it might be 5 to 10 times the mass of our own planet and up to 20 times further away than Neptune. The astronomical unit equals the distance between our planet and the Sun. Pluto is approximately 40 astronomical units from the Sun, but Planet 9, if it exists, is 400 to 800 astronomical units away. It would take 10,000 to 20,000 Earth years for this mysterious planet to make a single circle around the Sun. This makes it harder for us to catch this space body. There's a theory Planet 9 may have formed between the orbits of Jupiter and Neptune, similar to the rest of the gas giants in our solar system. The gravitational force of one of the two huge planets probably kicked it out of its orbit. Oh no. Then Planet 9 could get ejected further away from the 8 planets we know about. It ended up as some sort of icy waste, quite small at the beginning. But as time went by, Planet 9 has cleared its orbit of frozen pieces of rock and dust and finally formed into a real planet. Another theory says that this could be a planet another star lost on its way while it was passing near our solar system. In any case, Planet 9 probably doesn't reflect that much sunlight since it's so far away. And astronomers aren't sure where exactly they should look for it. Space is dark, mysterious, endless, obviously. But if we do find Planet 9, it will be the first solid proof there are more planets in our solar system than we thought. Moving on to an interesting exoplanet, located only 90 light-years away from us. An exoplanet is generally a planet located outside our solar system. This one has an atmosphere with water clouds. 1 year there lasts 24 Earth days, and the planet travels around a red dwarf star, which is way dimmer and smaller than our Sun. That's why, even though the planet is 8 times closer to its star than we are to our Sun, the temperature there is similar to that on our planet. This exoplanet has a size similar to Neptune. It's also less dense, which means it's mostly made of gas, unlike Earth, which is made of rock. The average temperatures there is 140 degrees, which makes it one of the coolest small exoplanets we've ever discovered. And the cooler the exoplanet is, the bigger the chance we'll find clouds in its atmosphere. Researchers have discovered more than 4,000 exoplanets, but all of them have been found within the Milky Way, at least until now. For the first time, astronomers may have spotted a planet outside our galaxy. They called it M51 ULS-1. The planet is located in the Whirlpool Galaxy, a distant spiral galaxy 28 million light-years away from us. There was once a huge but pretty young star that got stuck in a gravitational dance with something that could be a dense neutron star, the collapsed core of a giant star, or a black hole. The star's dance partner had incredibly strong gravity. It was feeding on the star, greedily ripping away its plasma. Then something unusual happened. An unknown, maybe even Saturn-sized object passed by and blocked this confrontation from our solar system. Now, no one can see what is going on. But this could potentially be the farthest planet we've ever discovered. There's a newly discovered planet outside our solar system. As large as Jupiter, it orbits 2 stars. And, as we can observe it from our planet, it crosses in front of them both. The full circle around these 2 stars, which means 1 year, takes approximately 200 Earth days. On the day of the discovery of the previous planet, scientists also found it had an unusual companion. It's an extra-hot Jupiter with an ultra-tight orbit around its star. The year there lasts only 1.9 Earth days. This planet has a weirdly shaped orbit. Also, it travels in the opposite direction from the rotation of its star. If you could travel 57 light-years away from our planet, you'd see something pink lurking in the darkness. As you get closer, it becomes bigger and more fascinating. Yup, it's a magenta-colored planet. A few billion miles away from its sun, this sky is one of the youngest planets scientists have discovered. It's only 100 to 200 million years old. It's made of pink gas, similar to our Jupiter. So, if you could fly closer to its surface, this gas would envelop you like a thick fog. You're coming closer and going deeper, and the gas is becoming darker, getting a reddish shade. And look at the planet's core. It's super hot. Because of its high temperature of 460 degrees Fahrenheit, this planet is like an oven. The heat is the reason the planet glows so brightly. You'll also notice the sky is hazy pink, with clouds made of droplets of frozen water, similar to ours. There is another exoplanet half as massive as Earth, which is one of the smallest planets we've ever found outside our solar system. It has a diameter of 5,600 miles. For comparison, Earth's diameter is 7,900 miles. The planet in question is mostly made of iron, similar to Mercury. Mercury has a massive iron core and a very thin crust, which makes it an oddball in our solar system. At its early stages, it collided with some space body at least once. That collision pulled its outer layers away, which is why only the firm iron core remained. Maybe this exoplanet participated in a huge space crash too. That's what probably took away the planet's mantle and left mostly its iron core. Or maybe this is just a remnant of a gaseous planet that used to be the size of Neptune. The atmosphere of the planet could be blown away by, let's say, a huge amount of radiation coming from the star. This planet is only 31 light-years away from us, and the day there is less than 8 Earth hours long. The planet is only a little bit bigger than Mars. People aren't likely to ever settle in that place because of its extreme temperatures that go up to 2,700 degrees Fahrenheit. There might even be molten lava on the side of the planet that faces its star. Such temperatures are high enough to evaporate any atmosphere, so this planet might have had one in the past. Generally, gas giants like Jupiter can't support life because they have extreme weather conditions, temperature, and pressure, and there are no building blocks that might create life. But smaller terrestrial planets, such as, Earth, have more key ingredients like oxygen and liquid water. Plus, they have more temperate weather and other conditions. And still, not all of such planets support life, of course. It's not easy to find a planet with similar conditions as the ones we have on Earth, or at least the conditions that would allow life to develop there. But meet Kepler-22b, one of our most promising findings. It's 600 light-years away from us, twice bigger than our planet, and with temperatures of about 72 degrees Fahrenheit. This is a so-called super-Earth. It's a category of planets unlike any we have in the solar system. They're more massive than Earth, but still lighter than ice giants such as Uranus or Neptune. Super-Earths can consist of rock, gas, or a mixture of these two. Kepler 22b is within the habitable zone of its parent star, which is less bright than our Sun. The planet probably has a rocky core. It may have an ocean, but it doesn't host any life. At least, we don't know about it yet. TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, oh, I'm not going to say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler 70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler 70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you?
My mother.
WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, And those clouds I mentioned are not made of water, but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that thumwerth. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat XO 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core.
At the edge of our solar system, there's a cold and mysterious region known as the Oort cloud. It's a hypothetical vast area of icy space objects surrounding the Sun. It's believed to lie far, far away from our star, from 2,000 to 5,000 astronomical units. For comparison, Pluto's orbit carries the planet between 30 and 50 astronomical units from the Sun. And there, in this freezing emptiness, a rogue planet may be hiding right at the moment. At least, that's what new research has recently suggested. Rogue planets are called this way because they don't orbit around any star. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Rogue planets are usually kicked out of their planetary systems, doomed to a solitary existence of circling the center of the galaxy on their own. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. At the same time, there might be billions or even trillions of rogue planets wandering around our galaxy. If these estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Anyway, in 1907, one astronomer started a search for Planet X. It's a hypothetical giant planet moving around the Sun beyond the orbit of Neptune. The scientist was convinced that this planet existed because he had observed some irregularities in the orbits of Uranus and Neptune. His idea led to the discovery of Pluto in 1930. But the dwarf planet was too small to have any serious gravitational impact on the orbit of Neptune, let alone Uranus. These days, the Planet X theory is largely considered to be discredited, but it hasn't stopped astronomers from searching for planets in the far reaches of our solar system. And shockingly, a new study claims there might be one or even more out there, but much, much further away than predicted. An international team of scientists has recently simulated the unstable celestial mechanisms of the early solar system. They've discovered that there's a possibility that a few planet-sized bodies might have come to rest in the Oort cloud. You see, about 4.5 billion years ago, when the solar system was just forming, it was a hectic and unsettled place. Gravity sent debris from the cooling protoplanetary dust cloud hurtling around like cosmic tennis balls. From time to time, large chunks of this debris, even planet-sized ones, were sent flying far enough to escape the sun's gravity altogether. Such pieces of debris turned into rogue planets. Researchers have seen such space wanderers in distant exoplanetary systems, but according to them, there's a 0.5% chance that one or more of those wayward planets formed in the solar system and ended up in the Oort cloud after drifting away from the sun. At the same time, it's slightly more likely that a rogue, Neptune-like planet was snagged by the sun's gravity from another planetary system. And then, this planet came to rest somewhere in the Oort cloud. The chances that this scenario is true reach 7%. If this turns out to be the case, then a space body similar to Planet X might indeed be hiding out there, on the outskirts of our solar system. The only problem is that it would still be too far away to have any impact on Neptune's orbit. In any case, most researchers are convinced that the Oort cloud is made up of a collection of way smaller icy objects. But given the distance to the Oort cloud and its enormous size, we may never really figure out what is lurking out there.
So check this out. Astronomers have discovered an exoplanet they're calling Super Saturn. It's got rings over an AU wide. An AU is the astronomical unit, the distance between the Sun to the Earth. That's an incredibly huge ring system, hence its name. Super Saturn is being called Mamajek's object after the astronomer who led the team to whom we owe the discovery. Professor Eric Mamajek of Rochester University in New York found Super Saturn while scouring through data downloaded from wide-angle transit observations. WASP is the acronym for Wide Angle Search for Exoplanets. It's an ingenious project developed in the year 2000 by astronomers at Queen's University in Belfast, Northern Ireland, and St Andrews University in Scotland. Using 4 telescopes, the CCD video cameras on the scopes record the slight dimming of starlight caused by objects passing in front of stars. This is called the transit method of exoplanet detection. So, for example, the planet Venus transits across our view of the Sun every couple hundred years. A black dot, the silhouette of Venus, is visible, crossing in front of the Sun as Venus passes between our line of sight and the Sun. This tiny eclipse causes the amount of sunlight coming to Earth to be reduced by a minuscule amount, also known as teeny tiny. The same is true for all the stars in the Milky Way that have planets going around them. Exoplanetary transits in front of stars must be in direct line of sight with Earth for the starlight to be dim. Such transits do not occur very often. That's why thousands of stars must be looked at simultaneously for as long of a duration as possible, between 4 and 8 hours a night. WASP was created to stare continuously at as wide of a range of stars as possible. maybe one of them would show an exoplanet transit. That translates into a lot of data being produced, about 40 gigabytes per viewing session. Computer scientists at Leicester University in England developed a computer program to store the data and generate photometric graphs of the light intensity of each star. Open University, also in England, joined the WASP project, took this data, and made it available for research by astronomers worldwide. The graphs of the intensity of starlight show that changes in its brightness are called light curves. These graphs have two axes. One is in the timeline axis, the other one is the intensity of light. As the object, considered an exoplanet, though it could also be a brown dwarf star, crosses in front of the star, the timeline axis keeps track of how swiftly it is moving. It tells us how close the object is to the star, while the brightness axis keeps track of how much the starlight dims. This way, we can find out how large the object is. Now, obviously, big objects will dim the light more and be easier to detect. At present, Earth-based equipment is not sensitive enough to measure the dimming caused by planets as small as Earth. Neptune's size and larger ones are the limit for WASP. However, the James Webb Space Telescope, which is now in operation, has a much greater sensitivity and will be able to resolve the transits of Earth-sized exoplanets. Now, I know you want me to get to Super Saturn, but there's something else you should be familiar with before we get there. If the exoplanet has an atmosphere, or, in the case of Super Saturn, a ring system, the starlight from the star the planet is transiting will shine through the atmosphere or ring system, and that can be detected too. The light curve will show less dimming in the photometric data, because not all the starlight is being blocked. Some light is still getting through the atmosphere or rings. This is important because it gives astronomers a reading of the atmosphere. The James Webb Space Telescope is fitted with spectroscopes that can determine the gas content of the transiting exoplanet atmospheres: oxygen, methane, carbon, etc. The WASP project has been really catching on. There's a Super WASP project now consisting of WASP North and a WASP South. One looks at the sky above the northern hemisphere, the other looks at the sky above the southern hemisphere. There's also a Next Generation Transit Survey, NGTS, based on the WASP project. It's automated, so astronomers don't have to stay up all night sipping coffee, but they can if they want to. Located at the European Southern Observatory in the Atacama Desert in Chile, the NGTS scans millions of stars and has discovered over 100 exoplanets, down to a size as small as 3 times the size of Earth. NGTS has started a Planet Hunters Club on social media. Citizen scientists can search the online database of light curves and perhaps discover your very own exoplanet. What had been a strictly British effort started by 1 or 2 astronomers is now a worldwide phenomenon. With the ability to read the spectroscopic signatures of atmospheric gases during exoplanet transits, a new idea emerged: technosignatures. That is, specifically identifying gases in exoplanet atmospheres that are produced by civilizations. The James Webb Space Telescope can do this. Gases from pollution, such as chlorofluorocarbons (CFCs), can be seen spectroscopically if present. Tritium from fusion reactions, if they have them, can also be detected, along with heat patterns from cities on the planet's surfaces. Technosignatures is a recent concept that originated after the WASP project started. Who knows what it will turn up? Now, let's get back to Super Saturn. The star that Super Saturn orbits is J1407, a small, dim, sun-like pre-main sequence star of the 13th magnitude. Huh? Well, the human eye can only see stars to about the 6th magnitude, and each magnitude is 2.5 times dimmer than the previous one. So it's not an exceptional star, just another telescopic star out there in the Scorpius-Centaur region of the night sky. J1407 is a young star that hasn't yet settled into its stable, long-duration phase. This is important because Super Saturn, officially J1407b, is showing signs of having a ring system in an early stage of development. Super Saturn's light curve was tucked away in the mountain of data from the Super WASP project. Professor Eric Mamajek and his associate Matthew Kenworthy of Leicester University studied the data thoroughly and produced a detailed report on it. Knowledge depends on good data. The horizontal axis of J1407b's light curve, the time axis, is what's causing all the hubbub. It took Super Saturn weeks to transit across in front of its parent star, 56 days to be exact. Planetary ring systems that we are familiar with in our solar system orbit right around the equators of the gas giant planets and are very thin, from only a few meters thick down to a few centimeters. In a telescope, Saturn's rings will seem to disappear when the planet is at zero inclination toward Earth. Saturn must be inclined at an angle in relation to Earth to see Saturn's beautiful ring system. It's something everyone should make a point of seeing: Saturn in a telescope. If Super Saturn's rings blocked most of the light from J1407 for 56 days, it means that the planet had to be orbiting at a steep inclination to its star. If it were at zero inclination, we wouldn't see the rings blocking any light. Therefore, the orbital time could be determined, 10 years minimum to 200 years if the orbit is highly elliptical. The superplanet itself is calculated to be 24 times the mass of Jupiter, which means that if it is gaseous, it could be a brown dwarf star. Super Saturn appears to have a Mars-sized object orbiting around it, because there is a huge gap in the rings that was most probably cleared out by a large object. The Cassini division in the rings of Saturn is where the moon Mimas has cleared out a path through Saturn's rings. The light curve of Super Saturn has only been observed once. All the exoplanet detection systems are keeping an eye out for it to come back around J1407. No one knows when that will occur. Some astronomers have suggested that J1407b is a brown dwarf star system in itself, merely passing in front of, but not connected to, star J1407. An orbital reappearance of Super Saturn would disprove that conjecture. The center region of Super Saturn blocked out all the light from its primary star. This is what indicates that the ring system is new and in an early developmental phase. Over time, the very dense ring mass close to the planet is expected to thin as all this matter gets absorbed into the planet or ejected into space. This is what has happened with our solar system's gas giant planets. The Mamajek object is a shocker. Never before or since has a light curve been detected like Super Saturn's. Super Saturn has added a new chapter to our understanding of the formation of ring systems. So, here's to you, Super Saturn. Hope to see you again soon.
When you explode planets, things get red hot. Atmospheres are stripped away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Some time before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart. And then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume. And finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains, covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1,600 of them. Unfortunately, you won't be able to do that because you press the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust. Then you spot bright burning meteors flying towards you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 1,200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach the blue marble of your home planet. What will its insides look like, scattered in space? From above, Earth looks pretty. 71% of its surface is blue, because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 feet thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then, the flying pieces get solid again. Ah, it's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 degrees Fahrenheit. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong, it evaporates smaller planets like Mars and Earth. The sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful: gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water, ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of the ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way, Neptune. It looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why, after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals.
Every April, a group of scientists observes the faint glow of asteroids passing by our planet. One year, they realized there was something weird shimmering in their telescopes. The team expected it to be another asteroid, but they ended up very surprised because what they discovered was an unusual space rock that didn't consist of the minerals that usually make up asteroids. It was made of silicate, the material mostly found on the moon. They named it Kamo'aliwa, which is a Hawaiian word that means wobbling celestial object. The rock didn't match any near-Earth asteroid scientists had already been familiar with. Instead, that piece had a pattern of reflected light, similar to that of the moon rocks astronauts had brought back from NASA missions. This fragment turned out to be a quasi-satellite, which is a kind of asteroids that orbit both our planet and the Sun. It repeatedly circles Earth and has a quite unusual tilt. That's the reason you can only see it in the night sky once a year. The fragment is pretty shy, too. It never gets closer to our planet than 9 million miles. That's almost 40 times as far away as the Moon. Plus, this space body often hides in the shadows. Scientists have figured out the piece won't stay in this orbit for a long time. It probably arrived at its current position about 500 years ago, and its orbit is likely to change in the next 300 years. this fragment may not be alone out there in space. There are at least 3 more similar near-Earth objects. They may have all come from the same place. Researchers aren't sure yet about the nature of the rock, but they can find out more about this unusual space object if they send a spacecraft to collect samples and bring them to Earth. That's something China's space agency is planning to do later this decade. Now, the moon appeared in the middle of chaos. There are several theories about how that happened. The first one claims the moon used to be just a wandering body, similar to an asteroid. It formed somewhere in our solar system. Once, it approached too close to Earth and got captured by our planet's gravity. The second theory says that our planet was spinning so quickly that some material broke off and started circling around it. One of the largest pieces was the moon. The third theory says that the moon was formed at a time when our planet was going through its own formation process. But today, the most widely accepted theory goes like this. Once, a long, long time ago, but not in a galaxy far, far away, Earth collided with a Mars-sized planet. The debris and clouds of dust from the collision gathered around our planet and started circling it. Eventually, something that we today know as the moon formed there. Apollo missions brought more than 1/3 of a ton of soil and rock from the lunar surface. These rocks show that the moon had mostly the same building materials as our planet. This might mean they have a common history. If the moon had been formed somewhere else and had been eventually captured by the gravitational force of our planet, it would have a different composition. Also, if it had been created at the same time as our planet or had once broken off, there would be the same minerals on both the moon and Earth. But the minerals on the moon contain less water. Plus, our planet's natural satellite is rich in materials that form fast at high temperatures. Now, the moon isn't the only space body in the solar system with a mysterious past. Hippocamp is Neptune's moon, discovered in 2013. It's the smallest moon of this ice giant, a mere 21 miles across. It's very close to Proteus, the biggest of Neptune's inner moons. And no, Hippocamp is not a place for big African mammals to spend the summer. Scientists think Hippocamp probably formed from debris after Proteus collided with a comet. If Hippocamp had entered Proteus's orbit from some other place in our solar system, the bigger moon would have either swallowed it or booted the tiny moon away. But not even Proteus itself is among the first generation of Neptune's moons. It was formed from the remains of the planet's earliest system of moons. Those first moons were destroyed when Neptune captured Triton, currently the largest of its moons. The main evidence proving the collision was likely to happen is the fact that Triton circles around Neptune backward, unlike other moons orbiting the planet. Neptune captured Triton from the Kuiper Belt. That's an area filled with icy objects and rocky debris stretching beyond Uranus. That means Hippocamp is a third-generation moon, kind of like a second cousin twice removed or something. Now, the Sun also had a turbulent past. Our star appeared about 4.6 billion years ago. It's hard to study its early stages of life since that happened 50 million years before our planet was even formed. But recently, a team of researchers has discovered crystals that are over 4.5 billion years old. Hidden deep within meteorites, they've revealed some things about the past of our Sun. Before the planets were formed, our solar system had consisted of a central star and a massive disk of dust and hot gas spiraling around it. As the dust and gases cooled down, they turned into minerals, including the crystals found in the meteorites that landed on our planet. Those ancient materials were irradiated, unlike some younger substances. Researchers think something might have happened to the Sun after those crystals were formed. Perhaps the activity of our star was less intense then. Or maybe, for some reason, these younger materials couldn't travel to the areas where irradiation was possible. Dwarf planets give us a chance to sneak a peek into the ancient years of the solar system. Around 4 billion years ago, Jupiter's, Saturn's, and Neptune's gravitational forces joined. They sent asteroids and comets hurtling across the solar system, making them collide with different planets. All the dwarf planets from the Kuiper Belt, for example Pluto, Eris, Haumea, Makemake, have their own moons that likely formed after some powerful collisions. Icy debris in orbits similar to Haumea's, for example, can prove the theory of an ancient collision. The debris it created simply didn't have enough energy to float away from the dwarf planet's gravitational pull. Ceres, another dwarf planet, has ammonia-rich clays on its surface. Ammonia isn't stable at the temperatures prevailing on Ceres. But there's plenty of this substance in the outer solar system. It means that Ceres was probably formed in those outer parts and got kicked inward. After all, the gas giants were migrating a lot at those early stages of the solar system. Or the dwarf planet could have formed in an asteroid belt, and ammonia somehow, let's say after a powerful impact, appeared on the dwarf planet. Ceres might help scientists understand icy moons better. The ocean floor on Earth has a high concentration of carbonate minerals, and some parts of Ceres have them too. This means this dwarf planet is like some sort of fossilized ocean world. Many exoplanets, a term used for planets outside the solar system, have also gone through pretty intense collisions in their early stages. This double star system is more than 300 light-years away from us, and its stars are at least 1 billion years old. Even though it's not young, this system still shows some signs of swirling clouds of dusty debris that haven't cooled down yet, which isn't something you'd expect from a star system of this age. This debris is still warm. It means there might have been a strong collision of two planets or some other space bodies of similar size in that region and relatively recently. So hey, everybody just simmer down. Dust particles circle around a young star. They stick together and grow bigger with time. That's how planets form. The leftover dust often settles in some distant cold areas. An example in our solar system is the Kuiper Belt. It's located far away beyond Neptune. As solar systems evolve, those particles keep colliding until they're so small they end up being pulled into nearby stars or kicked out of the system. Uranus spins on its side if you compare it with the rest of the planets in our solar system, and the only way we can explain it is a powerful collision in the past. Something much bigger than a regular comet or some other space body of similar size likely hit Uranus and knocked the planet on the side. It was probably a planet twice the size of Earth. It could be a protoplanet. This is a space body made up mostly of ice and rock that orbits a star and is likely to develop into a planet sometime in the future. Anyway, the fallout from the impact smothered the core of Uranus. It prevented the heat inside the planet from escaping. This might explain why Uranus has extremely cold temperatures on its surface. Man, bring a jacket and a blanket.
There are almost no similarities between Earth and Jupiter. Ours is a sweet, small planet with plants and cute pandas. Jupiter is a giant gas horror with furious hurricanes which never subside. And if you fall into this planet, you might literally fly through it. But what would happen if our Earth was the size of the father of the solar system? Oh, this is going to be fun. Jupiter is a planet so big that I bet you can't even imagine its scale. Its radius is about 11 times the radius of Earth, and it's about 316 times more massive. So, to turn Earth into another Jupiter, we'd need to increase its radius by 11 times. If the planet's density remained the same, then the mass of our new Earth would increase greatly. Actually, it'd be as much as 4 times larger than Jupiter's. Of course, these changes wouldn't go smoothly. The very first thing that we would immediately notice, nope, not the size, gravity. It would increase by about 11 times compared to old Earth's. Scientists say we can actually survive on a planet with greater gravity, but only if it's less than 5 times stronger than what we have now. Well, let's assume that we're daredevils, always ready to challenge nature. What would our life be like? Well, not very pleasant. After each step, you'd have to sit down on a bench and take a break, as if you've just run a marathon. Yes, it would be that hard to walk. Oh, and good luck with getting up later. In order to somehow move around this planet, we'd have to pump up very strong muscles. No more problems with junk food, because you'd have to become a heavy lifter just to get to the refrigerator. The force of gravity affects not only movement, but also the size of everything. Do you know that many astronauts gain some height due to weightlessness in space? So if you're worried about being short, here's a solution for you. On the other hand, strong gravity would make us all shorter. This would go not only for humans, but for everything on our planet. Trees would become very small. To grow upward, they would have to move water from their roots to branches, which would be unrealistic with such gravity. so they'd all turn into little bushes. Also, no more mountains. Even the largest ones would become very small. But at least, now, everyone would be able to conquer Everest. This would also apply to animals. Our pets would have to quickly evolve into pumped-up corgis just to be able to walk somehow. Oh, and say goodbye to birds, of course. If you think that's not enough suffering, let's add another thing. It would be very difficult for us to breathe. Atmospheric pressure would increase dramatically. That's because Earth would start to pull air toward itself with great force. You'd literally feel the weight of it on your shoulders. Remember what I said about taking a break after each step? Now, imagine that you'd also have to breathe through a pillow. Yeah. And that's not all. Atmospheric pressure plays an important role in the behavior of water molecules. It would be much more difficult for water to boil or turn into ice. Most icebergs would melt, and it's possible that we'd have no more clouds, too. All water vapor would come crashing down on us in giant torrents of rain. We'd be lucky if we didn't get flooded instantly. But, oddly enough, there would also be some advantages. For example, everything around us would become much more spacious. Assuming we didn't get flooded, there would even be a bunch of deserted areas on the planet. Maybe land prices would finally fall. But these unexplored areas would most likely remain unexplored, since we'd hardly be able to travel across seas and oceans. Not only because moving across the water would be incredibly difficult, but also because all water bodies on the planet would become 10 times larger. The very thought of getting lost in the ocean is frightening, but imagine if it was 10 times deeper and bigger? Uh-oh. So, no more sailing. And forget about flying by plane, or visiting space ever again. But it seems like it's still not all. If Earth was the size of Jupiter, we'd also have volcanoes raging everywhere. Due to the increase in its mass, Earth would become terribly unstable. All extinct volcanoes would become active again, and there would be lava and poisonous gases everywhere. In 1883, there was the most destructive eruption in the history of humankind, the eruption of the Krakatoa volcano. It occurred on one small island, but people all over the planet could feel the consequences. The eruption destroyed the island, triggered many tsunamis, and clouds of poisonous gases spread for miles. Now imagine this, but 10 times worse. That's what would happen on our Jupiter-sized Earth. It would probably be similar to the fall of the Chicxulub meteorite, the one that wiped dinosaurs off the face of the Earth. Then, poisonous gases spread all over the planet, causing one of the greatest massive extinctions in the history of Earth. Oh, and we would also lose the magnetic field, like the cherry on top of the cake. The magnetic field is very important for life on Earth. According to Rory Barnes from the University of Washington, it shields life on the planet from the nastiness of space, which means all sorts of radiation and solar winds. There's a molten iron core inside our planet that is responsible for producing the magnetic field. If the amount of pressure on this core increased due to gravity, it could solidify. And because of this, Earth's magnetic field would disappear. We would be exposed to the effects of cosmic radiation. Too scary to even imagine. Alright, so now we know that living on this new Earth would be a real nightmare. But what about outer space? You've probably heard that Jupiter, thanks to its strong gravity, protects us from asteroids. Well, this would become our job. Jupiter experiences about 24,000 collisions a year, and now it'd be our destiny. Do you remember me mentioning the Chicxulub meteorite? Similar tragedies happen to our planet once every 100 million years or so. But if it became the size of Jupiter, these guys would visit us every Friday. Also, we'd have to say bye-bye to the moon. Our natural satellite is too close to us. So if Earth grew in size, it would be a real catastrophe. We would literally watch the moon being torn apart in the sky. Of course, after that, all these fragments would crash into us. One of the theories claims that billions of years ago, the moon somehow separated from Earth, and its pieces gathered into a ball. Now, it would be like watching its creation rewind. And even if the moon survived, somehow remaining in Earth's orbit, the changes in the tides would still be dramatic. The consequences of these changes would be very unpredictable, but probably a bunch of tsunamis would be some of them. On the other hand, we'd probably gain a couple of new moons. Jupiter has as many as 79 of them. It would probably be a spectacular view, if only gas clouds from all those volcanic eruptions didn't block it. Also, the appearance of a second giant planet would have significant consequences for the whole solar system. Don't worry, other planets wouldn't crash into us. Many people underestimate just how far the planets are from one another. But still, the new Earth would shift the orbits of other planets a little and affect the rotation speed. And Earth itself would rotate around the Sun much more slowly because of its huge mass. For example, 1 year equals 12 Earth years on Jupiter. All this, of course, would greatly affect seasons and the climate in general. So, would there be life on Earth? Bold of you to even ask this question. But if one day we do manage to find a habitable super-Earth close to Jupiter in size, it would be very interesting to take a look at it.
Hey space buffs, just how well do you know our solar system? Guess the planet. It's more than twice as massive as all the other planets combined. It's covered with striking swirls and stripes, which are actually windy clouds of cold ammonia and water, floating in an atmosphere of hydrogen and helium. Still no clue? Then look at this. It's the infamous Great Red Spot, a giant storm larger than our home planet that has been raging for hundreds of years. Right you are. This cloudy world is Jupiter, and the main question is this planet our enemy or friend? NASA's Juno orbiter is exploring this gas giant at the moment, sending us tons of useful data. Jupiter is so big that 11 Earths could fit across its equator. If our planet was the size of a grape, Jupiter would be a basketball. The gas giant is the fifth planet from the Sun, orbiting around 484 million miles away. And even though for us Earthlings, our blue-green world seems to be the most important among all the other planets, we live in Jupiter's solar system. After all, it accounts for 75% of the mass of all the planets in our star system. And it's also 318 times more massive than Earth. And whatever Jupiter wants, Jupiter gets. Jupiter wants to throw stuff across the solar system? No problem. After all, this gas giant doesn't have its immense gravity for nothing. It yanks material from the asteroid belt, stopping poor space rocks from forming anything larger than Ceres, the only dwarf planet located in the inner solar system. Jupiter is hungry, it gobbles up comets, asteroids, and whatnot. Jupiter's bored. It hurdles everything it manages to capture on wayward trajectories. This gas giant must have caused a lot of destruction over the course of its life, which is around 4.5 billion years. But here's the thing. Some scientists think that we might owe our very existence and the existence of our planet to Jupiter's protective gravity. It may sound confusing, but by greedily swallowing up dangerous space objects, this planet vacuums the solar system. Other astronomers don't agree with this theory. They claim Jupiter is a hooligan, bothering peaceful and safe comets and sending them to unexpected places. You see, some of the most dangerous objects in our solar system are long-period comets. Those are huge chunks of ice and rock coming from the depths of the Oort cloud, which lies far beyond Pluto. Some of them get pushed into the inner solar system, where they dash past the Sun. There's a chance that the most devastating extinction on Earth was caused by a long-period comet. As such comets make their way through the solar system, they likely interact with Jupiter's gravity. The gas giant pushes them this way and that, consuming some of them like delicious ice rock burgers. But does Jupiter push such comets out of their dangerous orbit so that they don't smash into Earth? Or does this gas giant actually divert the trajectories of the comets that would otherwise miss Earth? No one knows. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen, the material stars are mostly made of. But the planet's mass isn't enough to start a fusion reaction in its core, and that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 75 times its current mass. Paradoxically, if Jupiter even got more massive, it would also get smaller. This additional mass would make the planet denser, and it would cause the gas giant to start pulling it in on itself. Astronomers are almost sure that even if Jupiter was 4 times its current mass, it would still remain the same size. Jupiter has between 80 and 95 moons, but one of the most popular ones these days is Europa. Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. That's what Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system, looks like. And the coolest thing about this faraway place, it might host life. Astronomers consider Europa to be one of the most promising places in the solar system to search for new forms of life. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it's still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. For a long time, scientists have been wondering about Jupiter's X-ray auroras. What causes them? It seems like the 40-year-old mystery has been solved. Jupiter's breathtaking X-ray auroral emissions are triggered by electrically charged particles called ions. They crash into the gas giant's atmosphere, and here's the result. But astronomers couldn't understand how those ions got to the atmosphere in the first place. But recently, they've seen the ions surfing Jupiter's magnetic field all the way down to the planet's atmosphere. Astronomers have received this data thanks to NASA's Juno spacecraft and ESA's XMM Newton telescope, situated in Earth's orbit. Now, on our home planet, auroras are only visible in a belt surrounding the magnetic poles, between 65 and 80 degrees latitude. Anything beyond 80 degrees and auroras disappear. But Jupiter's X-ray auroras are much more inconsistent. They pulsate regularly poleward of the main belt, and sometimes they're different at the north and south poles. Scientists have figured out that this pulsation is caused by the fluctuations in Jupiter's magnetic field. You see, when the planet rotates, it drags behind its magnetic field. Struck by the particles of the solar wind, it gets compressed. This heats the particles trapped in Jupiter's magnetic field, and they start moving along the magnetic field lines, producing magnificent auroras. Another feature Jupiter is famous for is its Great Red Spot, an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the surrounding cloud tops. The storm is more than twice as wide as our planet. At the edges of the storm, the wind speeds reach 270 to 420 miles per hour. That's faster than Earth's tornadoes. The hot gases in the planet's atmosphere are always moving, rising, falling, and swirling. Just like on our planet when cooler and hotter gases mix and merge into one another, they form giant circling storms. Astronomers think that once several enormous storms could have come together, creating the Great Red Spot. And now it keeps raging by constantly drawing cool gases from below and hot gases from above. Plus, this monster of a storm absorbs other, smaller vortices. They make the spot even more powerful. Several theories try to explain why the storm has its trademark color. It varies from whitish and pale salmon to orange and brick red. Some scientists believe the answer lies below the Great Red Spot, closer to the planet's surface. A colorless layer of ammonium hydrosulfide might be reacting with the cosmic rays or the UV radiation coming from the sun. This somehow gives the spot its pretty red color, but so far, it's just a theory. Astronomers have been observing the Great Red Spot since the 1830s. And for the first time, the storm was spotted in 1665 and described as the permanent spot. In other words, the storm is almost 400 years old. Strangely, it's been shrinking in size since the beginning of the 21st century. In 2019, it began flaking at the edges, with small pieces breaking off and vanishing. If this process continues, by 2040, the Great Red Spot might become circular, or it may simply disappear.
The oldest black holes we've ever seen, a measurement of distant starlight that threatens to bring the standards of cosmology crashing down, and even a preview of our solar system's gory demise. All these discoveries were made by the James Webb Space Telescope in 2023. Let's find out more about these and other stunning findings of the powerful space instrument. Soon after coming online in 2022, James Webb discovered 6 ginormous galaxies containing almost as many stars as the Milky Way. They dated a mere 500 million years after the Big Bang. It put into doubt our current understanding of the universe, pointing to a deepening mystery of how giant galaxies first appeared in the universe. After having conducted a few simulations, though, some astronomers now claim that the galaxies might not be so ancient. They could just be glowing unusually brightly. James Webb has also found the oldest black hole in the universe and did it twice. The first one, called Sears 1019, had a mass 10 million times that of the Sun. It was found by the telescope a mere 570 million years after the Big Bang. But James Webb didn't rest on its laurels. It discovered an even older, massive black hole. It appeared 440 million years after the beginning of the universe. How these enormous space-time raptures grew to such gigantic scale so early on is a baffling mystery. At the moment, astronomers are considering the idea of black holes forming from the rapid collapse of giant clouds of gas. At the same time, some black holes could have been seeded by hypothesized primordial black holes. Those are believed to have been created mere moments after the universe began. The Webb telescope has also cast doubt on the standard model of cosmology. You see, the universe is expanding, but it's doing so at different rates, depending on where we look. In the past, the 2 best experiments measuring the expansion rate showed different results. Cosmologists thought it could be due to some uncertainties in the work of the Hubble Space Telescope. But James Webb snuffed out that hope, providing researchers with yet another speed of expansion. One more astonishing discovery was dozens of unexplainable rogue objects floating through space in pairs. Those are couples of Jupiter-sized space bodies. Some of them were spotted as far apart from each other as 390 times the distance between Earth and the Sun. These objects are too small to be stars, but they're also unlikely to be rogue planets ejected from their solar systems. Now, this next discovery is even cooler. The JWST has an amazing ability. It can measure a spectrum of the atmospheres of distant exoplanets. This feature allowed it to spot the potential signs of life in a water world located 120 light-years away from Earth. This exoplanet is a sub-Neptune planet, weighing somewhere between the mass of Earth and Neptune. It orbits in the habitable zone of a red dwarf star. After examining its atmosphere, James Webb discovered that it was rich in hydrogen, methane, and carbon dioxide. These are chemical markers of a hydrogen-rich world that is likely to host extraterrestrial life. Now, stars and galaxies aren't spread through the universe evenly. They're connected by an enormous cosmic web. You can think of it as a network of crisscrossing celestial superhighways paved with hydrogen gas and dark matter. And the James Webb Telescope spotted the earliest strands of this web ever seen. It was a gassy tendril made of 10 closely packed galaxies spanning more than 3 million light-years in length. It formed when the universe was just 830 million years old. The tendril is partially wrapped around a bright black hole. Another phenomenon on James Webb's list of space distance records was the most distant gravitationally lensed object. It's an Einstein ring, produced by the warping of light from a distant galaxy around a mysterious dense foreground galaxy. How distant is it, you may ask? 21 billion light years away. That's how. And given the universe is only 13.8 billion years of age, the light from the galaxy has traveled almost twice that distance due to the expansion of space. And finally, James Webb has zoomed in on a gory preview of the sun's distant future. This ring-shaped space object is Ring Nebula, 2,200 light-years remains of an exploded star. At its center, there's a tiny white dwarf, the last remaining piece of the star's core, left after it exploded outward. The explosion most likely destroyed or ejected all unfortunate planets in its way. A similar fate is likely to befall our own solar system in 5 billion years.
The James Webb Space Telescope has recently discovered the oldest black hole ever found. It's an ancient monster as massive as 1.6 million suns, and it's lurking 13 billion years in the past at the center of an infant galaxy. This supermassive black hole appeared a mere 440 million years after the beginning of the universe. But it's just one of the countless black holes that inflated to terrifying scales during the dawn of the cosmos. It's the period about 100 million years after the Big Bang. That's when the young universe started to glow for 1 billion years. This discovery of the universe's oldest black hole can provide astronomers with the answers to some vital questions. For example, how could these space whirlpools balloon in scale so fast after the universe began? Or how did they appear in the first place? You see, black holes in the early universe couldn't grow as quietly and steadily as many modern black holes do. They were bound to experience some peculiar formation and growth. At the same time, closer to the present day, black holes are believed to be born from the collapse of ginormous stars. They grow by munching on gas, dust, stars, and other black holes non-stop. The friction created in the process makes the material, spiraling into a black hole, heat up, and it emits light that can be detected by our telescopes. To spot the oldest black hole, scientists used 2 infrared cameras, the JWST's mid-infrared instrument and near-infrared camera. They used the camera's built-in spectrographs to break down the light it had been recording into its component frequencies. While examining the results, they discovered unusual spikes among certain frequencies. It could only mean that the hot material around a massive black hole was beaming out faint traces of light. One of the most popular explanations for how ancient black holes grew so rapidly is that they appeared after sudden collapses of colossal gas clouds. Or they could form as a result of merges between clumps of stars and black holes. There's also a possibility that some of the oldest black holes could have been seeded by hypothetical primordial black holes. Those are believed to have appeared moments after the universe began, but their existence hasn't been proven yet. In any case, this most recent finding of the ancient black hole is extremely important because the formation of galaxies and the appearance of black holes go hand in hand. Every normal-sized galaxy that we know of has a black hole at its center. But even though such black holes are massive and can weigh millions and billions of solar masses, they are still tiny in comparison with their home galaxies. A supermassive black hole usually reaches less than 1% of the mass of a regular-sized galaxy and has a volume that is billions of times smaller. And still, somehow, supermassive black holes can influence galaxies, controlling the formation of stars for billions of years. The thing is, black holes exert an enormous gravitational pull on their surroundings. Any gas, dust, and stars that come too close to a black hole find themselves trapped. A lot of material crams into the space around the black hole and heats up, because that's what materials do when compressed. Soon, everything around the black hole flattens into a thin disk, which is called the accretion disk, and starts swirling around the black hole. Astronomers believe that this process is behind the mysterious relationship between black holes and their host galaxies. It's a connection between the mass of the supermassive black hole and the velocity dispersion of the gas in the galactic core. This cycle also controls the rate of star formation, which is a crucial element of the evolution of galaxies. If this delicately balanced process goes off kilter, the outflows from black holes can get too strong, not only heating the gas in a galaxy, but also removing it altogether. And then, the formation of stars doesn't simply slow down, it stops completely. Major galactic merger events can lead to such dramatic consequences because too much material falls into the central black hole too fast.
This is the James Webb Space Telescope, and this is how far we can see through its eyes. Impressive. But let's zoom further. Further! Further! The image is getting blurrier and blurrier. Wait! What is this shadow? It's a giant telescope capable of seeing those seemingly blurry images in perfect detail. NASA's Roman telescope is to be launched in 2027, and it might help us unravel the mysteries of the universe, including the essence of dark matter. No worries, James Webb will continue to show us the beauty of the cosmos and solve mysteries one by one. But astronomers have a new mission these days. They want to deploy the next, even bigger space telescope. And this mission is already well underway. The Nancy Grace Roman Space Telescope is likely to start a new age for astronomy. Scientists hope that the telescope will gather more data than any other NASA mission has ever done. Hubble and Webb are incredibly good at zooming in to get a clear, detailed view of small parts of the sky. Meanwhile, Roman is going to provide us with a much wider field of view. It will be capable of creating infrared images 200 times larger than Hubble. At the same time, it will have a similarly high level of detail. But even though the new telescope will be able to produce perfect images, it's going to be used mainly for surveys. Let's say we need to look for the star population in a nearby galaxy. But it's a too large field of view for Hubble. If we use it, we'll have to stitch lots of different shots and create mosaics out of them. But with Roman, a picture of the entire galaxy can be taken in one single shot. Look at this recent mosaic of our neighbor, the Andromeda Galaxy. This image was put together using 400 individual images taken by Hubble. And Roman will paint the same ultra-vast picture with the same level of detail with just 2 images. It not only sounds cool, it also means an unprecedented amount of data collected. Once we have such a panoramic view of the universe, NASA and other space agencies will probably be able to answer some of the greatest questions that have been intriguing humanity for ages. One of the main goals is to test the theory of relativity suggested by Albert Einstein. It's been well tested on the scale of our solar system, but not so much on larger cosmological scales. According to this theory, visible matter is supposed to slow down the expansion of the universe. But the universe is expanding non-stop, and doing it faster and faster. So, astronomers attribute this ever-growing expansion speed to a mysterious component, dark energy. They believe that it makes up around 68% of the universe. Hopefully, Roman will provide us with data that will help us accurately measure the position and distance between us and millions of galaxies. Eventually, it might let us figure out the expansion rate of the universe in different areas. In the end, the results might tell us whether Einstein's theory of gravity needs modification. One more of Roman's main goals is to detect hundreds and thousands of new exoplanets within our home Milky Way galaxy. The telescope will be able to do it using the technique known as gravitational microlensing. You see, when two stars align with each other, the one positioned in front distorts and magnifies the light of the other star located behind. And if the star in the foreground has a planet, we can see how this planet affects the light of the star behind it. Roman will hopefully count billions of stars, providing us with a very good census of how many of these stars have exoplanets. The cutting-edge telescope will not only spot new exoplanets, it will also carry another crucial instrument called a coronagraph. It can image exoplanets that are close to their parent star. This is actually an extremely tricky technique since the starlight has to be suppressed. After all, it's much brighter than the objects you want to study. By those objects, I mean nearby planets. The chronograph on the Roman telescope will try to capture large Jupiter-like planets directly by conducting live corrections to improve the quality of images. If it proves to work properly, the telescope will make a great demonstration instrument, forming the baseline for the technology that will be used on future space observatories. Such observatories will be capable of directly capturing Earth-like planets in the habitable zone of their parent stars. But the Roman Space Telescope isn't the only project that can change the way we explore space. There are other concepts, like Nautilus. It's an idea of a revolutionary space telescope based on a novel technology: special optical elements. Such elements can potentially allow us to overcome the main limitations of space telescopes: non-scalable primary mirrors. The Nautilus technology can provide large but ultra-light telescope apertures, enabling the launch of a massive fleet of identical telescopes. They will have an impressive light collecting power, which will help Nautilus survey thousands of Earth-sized planets located in the habitable zone of their stars. As a result, we might find atmospheric signatures of life on those planets. Over the past 2 billion years, the atmosphere of our planet has changed dramatically. The abundance of free molecular oxygen and ozone, which are highly reactive gases, together with water vapor and methane, represent a unique atmospheric composition. The presence of these gases, biosignatures, in the atmosphere of our planet is a sign of life that can be detected from afar. We're speaking about galactic distances here, but to identify such fingerprints of atmospheric components in the light reflected by or transmitted through the atmospheres of Earth-like planets, we need very large telescopes. NASA's Kepler mission has discovered more than 4,000 planets. And still, no existing, or even planned, space telescope has a diameter that is large enough to search for life in exoplanets' atmospheres. Finding and interpreting observations of extraterrestrial life correctly is very difficult. But the Nautilus team hopes to build a telescope capable of studying thousands of Earth-like planets. Then, there's the European Space Agency's Euclid mission. It's designed to explore the composition and evolution of the dark universe. The mission was named after Greek mathematician Euclid, who lived in Alexandria around 300 years BCE. He founded the subject of geometry, and since the density of energy and matter is tightly linked to the geometry of the universe, the mission was named in his honor. This space telescope will create a great 3D map of the large-scale structure of the universe across space and time. It'll do it by observing billions of galaxies across more than a third of the sky. Euclid will try to figure out how the universe has expanded and how its structure is formed over the course of cosmic history. Hopefully, it will reveal more about the role of gravity and the very nature of dark matter and dark energy. As we already know, dark energy likely accelerates the expansion of the universe. As for dark matter, it controls the growth of cosmic structures. But experts remain unsure about what dark energy and dark matter are. By observing the evolution of the universe over the past 10 billion years, we might finally figure out how it has been expanding and changing. From this, astronomers might infer the properties of dark energy, dark matter, and gravity. It could help find out more about their precise nature. The Euclid spacecraft is around 15 feet tall and 12 feet wide. It consists of 2 main components: the payload module and the service module. The payload module includes a 4-foot diameter telescope and 2 scientific instruments. a visible wavelength camera, and a near-infrared camera, or spectrometer. As for the service module, it contains satellite systems, such as electric power generation and distribution, data processing electronics, thermal control equipment, and so on.
You're gazing up at the night sky. Wow! For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy. So if they were to point their telescopes at our Sun, sooner or later they would see a small dot that passes between our home star and the observer. This is called a transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomenon right at home with a telescope. You have to point it at the Sun and wait. Then you'll see Mercury. That's the closest planet to the Sun, and now you see it as a small dot. Mercury transit process can last about 5 hours, and this phenomenon happens about 14 times in a century. You'll be able to observe the next transit on November 13th, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun, but because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the Sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit between the Sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the Sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700-plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot. And they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So, while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light-years from our home. Near the Ross 128 star, a red dwarf in the constellation Virgo. There's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the Sun on a regular basis for 2,000 years. But about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system. And 4 of them are in the habitable zone of the star. But they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, we use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. And the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope, and we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then a human being itself, of course. Below is a diagram of our solar system. Earth, the third planet from the Sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option how to deliver a message to a distant planet is to literally send a mail delivery there. It could be a space probe. And we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disk contains greetings in 55 Earth languages, a lot of music from different parts of our planet. Different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. These are pictures of people and earthly landscapes. In these pictures, there's information about the Sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the Sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the Sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Now suppose we made contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine we still got a return signal. It would be the slowest chat in history, because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space. So we have to take the first step. Although Proxima Centauri is the closest star to our solar system, it takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light-years wide. So the journey from edge to edge would take 100 millennia. So, we either have to cheat the laws of physics or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great and many more greats of the first crew will be able to see another star system from the spaceship portal. Hey, can you move your head? I'm trying to see out the window.
Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years, but finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now. But it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune, with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot. So the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper Belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper Belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think.
At the edge of our solar system, there's a cold and mysterious region known as the Oort cloud. It's a hypothetical vast area of icy space objects surrounding the Sun. It's believed to lie far, far away from our star, from 2,000 to 5,000 astronomical units. For comparison, Pluto's orbit carries the planet between 30 and 50 astronomical units from the Sun. And there, in this freezing emptiness, a rogue planet may be hiding right at the moment. At least, that's what new research has recently suggested. Rogue planets are called this way because they don't orbit around any star. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Rogue planets are usually kicked out of their planetary systems, doomed to a solitary existence of circling the center of the galaxy on their own. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. At the same time, there might be billions or even trillions of rogue planets wandering around our galaxy. If these estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Anyway, in 1907, one astronomer started a search for Planet X. It's a hypothetical giant planet moving around the Sun beyond the orbit of Neptune. The scientist was convinced that this planet existed because he had observed some irregularities in the orbits of Uranus and Neptune. His idea led to the discovery of Pluto in 1930. But the dwarf planet was too small to have any serious gravitational impact on the orbit of Neptune, let alone Uranus. These days, the Planet X theory is largely considered to be discredited, but it hasn't stopped astronomers from searching for planets in the far reaches of our solar system. And shockingly, a new study claims there might be one or even more out there, but much, much further away than predicted. An international team of scientists has recently simulated the unstable celestial mechanisms of the early solar system. They've discovered that there's a possibility that a few planet-sized bodies might have come to rest in the Oort cloud. You see, about 4.5 billion years ago, when the solar system was just forming, it was a hectic and unsettled place. Gravity sent debris from the cooling protoplanetary dust cloud hurtling around like cosmic tennis balls. From time to time, large chunks of this debris, even planet-sized ones, were sent flying far enough to escape the Sun's gravity altogether. Such pieces of debris turned into rogue planets. Researchers have seen such space wanderers in distant exoplanetary systems, but according to them, there's a 0.5% chance that one or more of those wayward planets formed in the solar system and ended up in the Oort cloud after drifting away from the Sun. At the same time, it's slightly more likely that a rogue, Neptune-like planet was snagged by the Sun's gravity from another planetary system. And then, this planet came to rest somewhere in the Oort cloud. The chances that this scenario is true reach 7%. If this turns out to be the case, then a space body similar to Planet X might indeed be hiding out there, on the outskirts of our solar system. The only problem is that it would still be too far away to have any impact on Neptune's orbit. In any case, most researchers are convinced that the Oort cloud is made up of a collection of way smaller icy objects. But given the distance to the Oort cloud and its enormous size, we may never really figure out what is lurking out there.
New research suggests that Mars might have all the necessary conditions for the appearance of life. Does it mean aliens could be already waiting for us on the red planet? Let's figure it out. On Mars, there are just the right conditions for photosynthesis beneath dusty ice layers in its mid-latitudes. And photosynthesis, the process used by plants, algae, and cyanobacteria to turn light into chemical energy, requires water and sunlight. On Mars, A thick layer of ice might filter out harmful solar radiation while letting enough light through to enable photosynthesis, creating what researchers call radiative habitable zones. This doesn't mean that, at the moment, life exists or has ever existed on Mars. At the same time, the findings give scientists clues about where to search for potential signs of life. Both Earth and Mars lie within the Sun's habitable zone, where temperatures can support liquid water. But while our planet's surface is covered with huge oceans, Mars appears dry and desolate. Yet evidence from NASA missions like Curiosity and Perseverance suggests it wasn't always this way. Ancient lakebeds and river channels show that water flowed on Mars billions of years ago. Today, water exists on Mars primarily as ice, often in surprising locations. Scientists believe Mars lost its liquid water when its magnetic field faded, which led to its atmosphere getting stripped away by solar winds. With little atmosphere left to trap heat, water vapor escaped into space, leaving the surface cold and dry. Without an ozone layer, Mars also faces intense ultraviolet radiation, which destroys the complex molecules essential for life. Mars gets about 30% more harmful UV radiation than Earth. But dusty ice layers could shield potential habitats from this radiation while still letting in enough sunlight for photosynthesis. Using computer simulations, researchers found that dust within Martian ice could cause it to melt from below, forming thin layers of liquid water. These pockets could be shielded from evaporation by the overlying ice, creating the two essential ingredients for photosynthesis: water and sunlight. Past studies also suggest that even small amounts of dust, less than 1%, in dense Martian snow, can enable melting in mid-latitudes. Observations of exposed dusty ice near Martian gullies also support the idea that these conditions could form shallow liquid water layers under the surface. At the same time, the amount of dust in the ice plays a critical role. Ice with too much dust blocks sunlight, while ice with just the right amount, from 0.01 to 0.1%, can create habitable zones at depths of 2 to 15 inches. Cleaner ice could allow these zones to form deeper, between 7 and 10 feet. As for Mars's polar regions, even though they're rich in ice, they are likely too cold for this melting to occur, making mid-latitudes a more promising target. Interestingly, similar habitats exist on Earth, providing an analog for what might happen on Mars. On Earth, cryoconite holes form when dust and sediment heat ice surfaces, melting them enough to create pockets of liquid water beneath. These translucent ice layers allow sunlight to go through, and researchers have discovered microorganisms living in these shallow subsurface environments. While they go dormant in winter, when sunlight returns in the summer, it reactivates these tiny ecosystems. While this research doesn't confirm the existence of life on Mars per se, it does open up new avenues for exploration. Understanding how dusty ice interacts with sunlight and melts could help identify potential habitable zones on the red planet. The research team is planning to refine their simulations to better pinpoint where and when melting might occur on Mars. They're also recreating these conditions in the lab to study them in greater detail. This work could provide important insights for future missions looking for signs of life on Mars.
Mars is the Earth's space cousin. It's the fourth planet in our solar system, about half the size of the Earth. It also has two small moon buddies, Phobos and Deimos. These moons are shaped like potatoes. Phobos is the drama king, moving closer to Mars and planning a crash landing in about 50 million years. Deimos is much calmer though, hanging out farther away from Mars. Mars got a cool nickname, the Red Planet, thanks to its rusty red surface. This color was so bright that it was spotted by astronomers many years ago. Even you can sometimes see it in the sky with the naked eye, a small scarlet dot. And maybe it has hot vibes, but in reality, Mars is a very cold desert. The temperatures there can drop as low as minus 240 degrees Fahrenheit. But was Mars always nothing more than a rusty-looking desert? Actually, no. Scientists believe that perhaps many years ago, this planet was similar to ours. Meet Curiosity, the detective rover made by NASA's Jet Propulsion Laboratory. Scientists want to know all about the Martian weather, landscape, and other stuff like that. Curiosity is a pretty heavy car-sized robot. It weighs about 1,985 pounds. It embarked on its journey on November 26, 2011. The rover pulled off a landing on Mars on August 6, 2012. Originally, Curiosity's mission was supposed to last for 2 years, but it's still going strong. Curiosity is basically a space lab on wheels. It's packed with cameras, spectrometers, radiation detectors, and sensors to sniff out the Martian environment. As Curiosity roams around, it rewinds Mars history. And during its mission, the rover discovered something incredible: signs of lakes and rivers from long ago. You see, Curiosity's favorite spot to play around is Gale Crater. It's a prehistoric Martian oasis where water might have hung out. There's this huge mountain in the middle called Mount Sharp. This place is taller than 10 Eiffel Towers stacked on top of each other. And it's got layers of rocks that hold Mars's ancient secrets. Recently, scientists spotted something great when studying Curiosity's data: mud tracks. What's so surprising about that? Well, these aren't just any old tracks. They're like messages from the past. They mean that the Martian ground used to get wet and then dry out again. The mud on the ground would shrink and crack during the drying phases, making these T-shaped junctions. Moreover, it seems like the ground on Mars went through several wet-dry cycles. It happened maybe up to 10 times. This made the junctions turn into Y-shaped cracks. When a bunch of Y-shaped cracks got together, they made a super cool pattern, something like a patchwork of hexagons. It looks just like honeycombs, or even a dragon's skin. Each of these hexagons are the size of candy. Similar cycles have happened on Earth, and they're linked to the birth of life. When water dries up, it leaves behind concentrated stuff that's great for chemical reactions, and these reactions might be the same ones that kickstart life. These hexagons have been hanging around for a really, really long time, billions of years. That means that Mars once had a climate kind of like Earth's, and maybe even life. In fact, the red planet even has some signs of water right now, in the form of hidden ice at the poles. Mars has the North and South poles, and just like with the Earth, they're red planet's ice caps. Picture the North Cap as a big, icy pancake about 620 miles wide. The South Cap is a bit smaller, about 220 miles wide, but it's got a thicker ice layer, almost like a snowball with a strong shell. When it's winter at the poles, it's an incredibly long nighttime. No sunlight, just chilly darkness. During that time, around 30% of the air turns into frozen CO2. It's dry ice, the same stuff that's often used in horror movies. But when the poles wake up to sunlight, the dry ice turns back into gas. All this freezing and thawing makes clouds and frost, just like on Earth. One time, a rover named Opportunity even caught some clouds made of water ice. But it doesn't necessarily mean Mars was once thriving just like the Earth. Life needs more than just wet, dry cycles to pop up. It needs the right atmosphere and other special ingredients. We're not sure if Mars had all of those, and even if it did, there's no guarantee that life actually happened. But this raises another very important question. Has Mars ever hosted tiny living creatures? Curiosity isn't the only robot that tries to find the answer to that. There's also a rover called Perseverance. It's trying to find clues about Martian life. It's digging into an old Martian crater, once filled with water. And like a space archaeologist, Perseverance is searching for fossilized signs of ancient critters. And here's the funny thing. Some scientists think that we've stumbled upon it almost half a century ago. The only problem is, we might have accidentally destroyed it. It happened even before Curiosity started rolling around Mars. Back in the 1980s, two cool NASA's landers, Viking 1 and Viking 2, made a pit stop on the red planet. These landers took a selfie, and then they also did some funky experiments on the Martian soil, all in the name of finding signs of life. What they found is some weird organic stuff called perchlorate. It's a compound that we use in fireworks or rocket fuel. But most results didn't seem that promising. They even mixed up some soil with water and nutrients, hoping that if there were Martian microbes, they'd snack on the goodies and return radioactive gas as a result. But unfortunately, that didn't happen. Now, here's the problem. Some scientists think that maybe the water they added back then actually destroyed those tiny Martian critters. Poor microbes were just hanging out and suddenly got soaked by a bunch of weird liquid. Something like this wouldn't be very pleasant for the Earth microbes. They live inside rocks and they're sucking water from the air. Pouring water on them would result in a total disaster. So, of course, giving them nutrients after that wouldn't do anything. If you've just barely survived a water bath, you're probably not in the mood for a feast. Perhaps these Martian buddies might have something called hydrogen peroxide in their cells. It helps them live in an extreme environment. If that's true, it could explain all the results from the experiments. You see, the instruments heated up the samples, so if there was hydrogen peroxide, it would have gone boom, wiping off the little guys and turning their cozy homes instantly. Imagine how ridiculous it would be if it turns out that we accidentally destroyed the only signs of life on Mars. Ideally, we need a new mission to Mars to test this theory. Let's hope it's not true. In any case, the journey isn't over. There are more missions planned for Mars, and humans might even visit this planet someday. The next mission is the Mars Sample Return. It's a super cool teamwork project between NASA and ESA. They're teaming up to bring back souvenirs from Mars, collected by NASA's trusty Mars Perseverance rover. There's going to be a whole bunch of spaceships. They'll work together to bring these precious Mars samples back. The samples are planned to arrive on Earth in the early to mid-2030s. And the fun doesn't stop at Mars. Our Mars missions are a warm-up for an even bigger adventure, exploring icy moons around Saturn and Jupiter. These moons have hidden oceans beneath their icy surfaces, and who knows what kinds of space secrets they're hiding. But whether it's Mars, icy moons, or beyond, our quest to find extraterrestrial life continues. In addition, we are slowly starting to find more and more organic materials on Mars, and maybe one day we'll finally find some microbes in our solar system. Let's hope for it and stay tuned. Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the Moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the Moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the Moon before, it was the first time a rock from the Moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the Moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the Moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the Moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the Moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the Moon's formation around 4.5 billion years ago. On the far side of the Moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the Moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the Moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the Moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory Mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human crewed space missions, but also as much needed